and welcome to my talk on normal flow. My name is Erin, and if you would like to follow along with the slides, they are available at normalflow.ez.codes. So these days on the web, you can see all kinds of blog posts, tutorials, and articles about all of the really cool stuff that CSS can do these days. So things like Flexbox, Grid, and the new container queries. And this is all very cool, but today I want to talk about something a little bit more fundamental. Today I want to talk about normal flow. So normal flow is the OG layout of the web. It's a layout that we had before we had Flexbox and Grid. It's a layout that we had even before we had tables. In fact, normal flow is so fundamental to layout on the web that if you look up the definition on MDN, what you actually get is the definition of what it isn't. So elements on a web layout in normal flow if you haven't applied any CSS to change the way they behave. So that means that as long as your element doesn't have display flex or grid or the inline variants, doesn't have a position of absolute, fixed, or sticky, it's not floated, it's not a column, and it's not a table, then it's normal flow. And in fact, it's even more insidious than that because layouts aren't inherited. So if we have a page that's all laid out in normal flow and we change, say, this form to use flex layout, then the form is laid out using flex, but the things inside the form are still laid out using normal flow. So if you're laying out anything on the web, at some point, you're going to be using normal flow, and understanding how it works and what it's trying to do is going to be really helpful. It's going to make your life a lot easier. So today I want to talk about what normal flow is for, how it works, and look at some cases of when not to use it. So the original intent of normal flow was for laying out documents. Right? The original use of the web was to share documents. Back then it was scientific articles, not online shops. And that's what normal flow was built for, right? That's what it's trying to make easy. And by documents, I mean things that are mostly text. They might be broken up into sections with headings. They might have images in them, but the basis of it is text. So if you're building something that doesn't follow that paradigm, then you might run into some troubles trying to use normal flow. Things might get a bit weird. So today we're going to find out the points where it's going to get weird and what we can do about that. It is probably worth mentioning, though, that even if you are building something that isn't mostly based on a text layout, there are probably parts of your page that are based on text, and in those cases, normal flow is probably going to work perfectly for you. Okay, so how does normal flow work? Well, when we're talking about HTML elements, we can break them up into two kinds of categories. There's elements that hold other elements. So the big container elements like article or section, the header elements, footer elements, all of the different list elements, all elements that you're going to put other elements inside of. And the second kind are elements that are content. So those are all of our different formatting elements and also image and video. Now, elements that hold other elements are called block elements, and elements that are content are called inline elements. And there's two rules about how we can lay things out. So with block elements, you can put anything inside them, right? So a block element can contain other block elements, it can contain inline elements, and it can contain text nodes. Inline elements, though, can only contain other inline elements or text nodes. And a text node is just text, right? It's not wrapped in an element at all. It's a text node. All right, so block elements can contain anything. Inline elements can only contain other inline elements and text nodes. Now, I say these are the rules. We are talking about browsers, though, so if you break these rules and put a block element inside an inline element, the browser will figure something out. But as far as it goes with like trying to build a mental model and understand what's going on, life is going to be easier if you try and follow these rules. Okay, so how do block elements work? So like I said, the block elements are the ones that can contain other elements. If you would like a block element that doesn't have any semantics attached to it, then you're looking for a div. And this whole thing is a lie, and actually there's no such thing as a block element. Anything that you apply CSS property of display block to becomes a block element. So when I say that an article, for instance, is a block element, what that means is that by default, the style sheet that the browser applies will apply display block to article elements. Now, like I said, you can change any element you like to a block element using display block, but if you find yourself doing that, I'd probably take a moment to think about why and if you're actually using the right element. Okay, so how does the layout work? Now, when we're talking about layout, we're talking about two things. We're talking about the size of the element and the position, so how big it is and where it is on the page. And for block elements, the size of the element by default will be the same size as the container, the same width as the container, and the height that it needs to be to fit its content in. So here you can see our element is the same width as the container, and the height that means that it fits this content. If we add more content, the element gets taller to fit the content. We can, of course, change the size of this element. So we jump in here. We can say that we want a width of, say, 200 pixels, and then the element will get smaller. You'll see there, though, that because this width is smaller than the content is now overflowing out of the element. And same thing if we set a height that's too small, it's now going to overflow vertically. Now, you might look at this and say, stupid browser, that looks ugly. Why would you do that? But you have to remember that what you're trying to achieve and what the browser is trying to achieve are often not quite the same thing. As developers, usually what we're trying to achieve is to make our design look like it does in Figma. What the browser is trying to achieve, though, is making sure the content is visible to the user, right? Its number one goal is that the content is visible. The other thing you should remember is that the information that's available to you is different to the information that's available to the browser. So when we're writing our code, we don't have access to much information, right? We don't know how big the screen is that it's going to be displayed on. We don't know what the resolution is. We don't really know for sure what font is being displayed. And often we don't even know what the content is, right? Usually that's some kind is dynamically generated. Like we don't know any of that stuff. The browser, however, knows all of that stuff. And it's trying to make sure that the content is visible and it's responsive by default, right? So it's going to make it visible, and if the viewport or the content changes, it will change the layout so that those things are still visible. So the point here is that as much as possible, you should let the browser do the layout, right? Give as much leeway as you can to the browser to sort things out, because it's going to make sure that things work. Things start breaking when developers get in and put too many restrictions on what the browser can do. Which is all well and good, but sometimes you really do need to set the size on something. So there's a couple of options that we've got here. We can do what we just did then and set it using an absolute unit. So like pixels or ems or rems or anything where, every time you use this, it's always going to be the same size, right? 300 pixels is always 300 pixels. 20 rem is always 20 rem for the same font size, right? It's an absolute size. We can also set the size relative to things. So the one you're probably most familiar with is that I can set the width of this element to be 30% of the width of the container by using %. We can also set the width of the element or the size of the element relative to the size of the viewport, where the viewport is just the screen, like the window that you can view in. So if we set the width of this to 30 VW, then the element will be 30% of the width of the viewport. We can also set it relative to the height of the viewport, and we can use this vmin and vmax, which means set the width relative to the width of the viewport or the height of the viewport, whichever is smaller for vmin or bigger for vmax. You might wonder why you want to set the width of something relative to the height of its parent. It can be helpful for making things that are like square. So we can set relative to the viewport. These days, something else we can do is set the size relative to the container. So in this case, the container, I don't mean the parent element. I mean specifically something that we've set up to be a container. So we can give some element a container type. We'll say size for this particular one. And then if we jump into our element here, we can say that we want the width to be 30 CQW, and it will now be 30% of the width of the container. Now, in this case, this is the same as 30% because the container is the parent, but the container could be any ancestor element. And just like with the viewport, we can also set it relative to the height. The other thing that we can set the content, or the width and the height relative to, is the content. So I can set the width of this element to be min content. And min content means that it will be the minimum width it can be while still fitting its content in it. So in practical terms, it's going to be the same width as the widest word usually. Or if we had like a big image in there, it would be the same width as the image. We can also set it to max content, which means it's going to be as big as it needs to be to fit all of its content on a single line. And we also have fit content, which looks the same as max content, but is a little bit different. So max content, if I add some more content in here, so that the content is bigger than the size of the parent, then this element is still going to put all of its content on a single line, and it's going to overflow its parent. If we change it to fit content, then it will wrap so that it always fits inside its parent. Cool. So there's some things that we can set the width relative to. There are some things that we can't set the size relative to, though, in normal flow. And the biggest one is that we can't set the size relative to the siblings. So say we have some stuff here. We have a container, and it's got a bunch of tags in it, and we want all of the tags to be the same size and just as big as they need to be to fit the content. We can't do this using normal flow. There's just no way to say, I want this tag, this element to be the same size as its siblings. This particular version here is actually done using grid, but I wouldn't recommend doing that. It's not the best solution. What I would recommend doing is just changing the HTML. So if we jump in here, and now we have our container element, but inside we have a subcontainer which has all of our tags in it. Then on this subcontainer element, we can give it a width of fit content, which means that this tag container is now going to be as wide as the largest tag, and the tags are all going to be as wide as their container, which means we get the layout that we're looking for. So this works for width. Unfortunately, we can't set the size of an element, the height of an element relative to its siblings. So this is a layout that everyone has tried to build at some point on the web, where we have a header and a footer, and then we have some content in the middle, and we just want the content to take up the available space, right? Whatever's left over after you can't factor in the header and the footer. There are ways to do this in normal flow. We could do something like this, where we set the height of the header, we set the height of the footer, and then we calculate the height of the content. This is not a good way to do this. If anything changes in this content and nobody thinks to update the CSS, it's going to break. If somebody views this page in German and suddenly the header is longer and it wraps onto 2 lines, this is going to break. It's generally a very brittle solution and not what I would recommend. Instead, we can just not use normal flow for this, and we can use flex. So if we set display flex on the container and we give it a flex direction of column, that means that the elements will be stacked vertically. And if we give the content flex 1, that means it will grow to take up the available space. Right, so sometimes normal flow isn't the answer. Okay, what about positioning? So by default, an element that's added using normal flow, the first element inside a container is going to be positioned at the top of the container, or at the start of the container. And every element after that is going to be positioned immediately below the previous element. So say the top or the start. If you're using a language that's written horizontally, so left to right like English or right to left like Arabic, then the start of the container is the top. If you're using a language that's written vertically, like traditional Chinese, Japanese, Korean, then the start of the container is actually the right-hand side, and these elements will stretch out to take up the entire vertical space. That said, on the modern web, languages that are traditionally written vertically are usually written horizontally. If you don't believe me, this is the website of Nintendo, arguably Japan's most important company. And as you can clearly see, the text is all written left to right. On the off chance that you don't speak Japanese, you can see this by just highlighting the text. You can see it highlights left to right. And the same is true of, like, if you go to Chinese Wikipedia or Korean Wikipedia, these are all languages that are traditionally written vertically, but on the web, they are usually written horizontally. So unless you know for sure that you need to deal with text that's written vertically, honestly, I just wouldn't worry about it. Okay, so by default, assuming our language is written horizontally, our elements are going to be placed at the top and then one after each other inside the container. We can change this vertical positioning using the margin top element. So if I give this a margin top of 40 pixels, the element with the margin is moved down, and all of the elements after it are also moved down, because elements are always positioned relative to their previous sibling. So you could say that when you change the layout, then that change flows along through the rest of the elements. That's what the flow in normal flow is. We can also make this value negative, in which case everything will move up. Be careful using these negative values though, because they can result in things overlapping with each other. We can also leave this element where it is and change the position of all the elements after it using margin bottom. So that would just push everything else down. One thing to note though is that if I give the first element a margin bottom and I give the second element a margin top of 40 pixels, the distance between them isn't 80 pixels, it's 40 pixels, right? So the margins are both there, but they overlap. They take up the same amount of space. So the distance between the two elements is just going to be whichever is the bigger of the two margins, not the two margins added together. So we can make this bigger now, it'll be 60 pixels, but if we make it smaller, it doesn't get smaller. And the reason for this is something called margin collapse, and it comes back to the fact that normal flow is intended for laying out documents. So the normal way, the usual way that we lay out documents is something like this, where we have headers which have a large margin, paragraphs which have maybe a medium-sized margin, and text which is going to have a very small margin around it, right? That's just the way that we like our text to flow. However, when we have a chapter, like a header that's followed by text, and we have a header that's followed by an image, we want the gap between the header and the thing that follows it to stay the same, no matter what kind of content it is, right? So we don't want the gap between a header and an image to be smaller than the gap between a header and text. So margin collapse makes this very easy, right? If you have a header and something else with a smaller margin, you're always just going to get the margin of the header, right? So again, this is how we lay out documents. This is what normal flow is intended for. If you're laying out documents, this is going to be great for you. If you're not, this might cause you problems. If it is causing you problems, have a look at margin collapse. There's a few solutions out there. Usually the simplest answer is to use padding instead of margins. All right, so that's vertical positioning. What about horizontal positioning? So let's make this element a bit smaller. Width, so we can see what's going on. Now, by default, an element is going to be positioned horizontally at the start of the container. So if we're using a left to right language like English, that's going to be the left. And if we're using a right to left language like Arabic, it's going to be on the right. We can move this just like we can move it vertically using margin. So we can say margin left of 40 pixels, we'll push it to the right, or minus 40 pixels, we'll pull it to the left. Problem with this is that margin left will only work if your language is left to right. If I apply a left margin to a right to left element, then it's not going to move it, right? It's just going to add margin after it. So to deal with that, instead of using this margin left, we can use the new logical properties. So we can say margin inline start. So inline direction is horizontally and vertical direction is called block direction. So just like block and inline elements. So yeah, if we add a margin inline start there, we get 40 pixels. Margin can also take this auto value, which means to put all of the available space into the margin. So if we do that here, we're going to end up with the element being pushed all the way to the end of the container. We can also just like sort of ditch the start there and just use margin inline, and we'll get an element that is centered horizontally. So that's nice. Unfortunately, this centering trick doesn't work with vertical margins, so we can't vertically center something by giving it a margin of auto. But if we think about it, that makes sense, right? Because if you're talking about the horizontal positioning of an element, there's only ever one element on the row, right? So centering that element is easy, it just goes in the middle. But when we're talking about vertically, there's potentially any number of elements in the vertical direction. So if I decided to center the first element, what would that mean? Like, it could mean that we're going to center it between the container and the next element, which that is centered, I guess. I mean, it looks like it's not because there's some padding on the parent, but it is. Or it could mean that we want to put all of the available space at the top and have that element centered in that. Or it could mean we want that element in the center of the container and then everything else after it. And what if we centered multiple elements? Like, what would that look like? I think you can see that trying to center a single element vertically when there could be lots of elements, it doesn't really make sense. So we don't use normal flow for that. If we do want to center elements though, we can do it. We just need to use flex instead. So here we apply flex to the container, so to the parent element. And if we give it justify content of center, then all of the elements inside will be squished into the center like this. There are different ways you can center elements. So instead of saying justify content center, we can do space around, space between, or space evenly, and you get different kinds of centering there. We also can't lay something out vertically relative to the end of the container, basically for the same kind of reasons that we can't center it. And again, flex is the answer to how to do this. If we give things justify content of end, then everything will be at the end of the container. There are a couple of other limitations to laying things out using normal flow. So we can't have block elements that sit next to each other. There's no way to get this kind of layout using block elements in normal flow. There are a few options to get this layout. Obviously, I've got it here. The old school way of doing it would be using float. I wouldn't recommend that. It's not really what float's intended for, and you'll run into some little problems with it. In this particular case, where we want to lay out where we have elements that are sitting next to each other, and we just want as many as will fit in a row, and they can all be different sizes, then this is a perfect use case for flex. So again, we just say we want to display flex, which says try and put everything on one row. Flex wrap means if everything doesn't fit on one row, then wrap onto another row. And align content start just means that the elements are all sort of squished up to the top there. If we remove that, then they'll spread out and take up all of the available space. So either of those are fine, just depending on what you're looking for. The other layout similar to this that we often want is something more like this version, where we want all of the elements to be the same size and we want the same number of elements on each row. So in that case, we can use grid. So again, here we're using display grid on the container. We're saying I want 3 columns, all the same size, and we're using that align content start is the same as it is in flex. And the final thing that we can't do when we're laying things out in normal flow, or laying out block elements in normal flow, is we can't position an element relative to its siblings. So I can't say that I want the Planet Express logo to be positioned to the right of those other 2 paragraphs. There's just no way to do this in normal flow. Instead, we can use grid again. So here we're saying we want the container to be a grid, and it's got 2 columns, and we want the logo to be in the second column on the second row. We also need to specify that we want that second paragraph to be in the third row. Otherwise, the browser will sort of go, oh, hey, there's an empty space in the second row. Let's just put it in there and be helpful and whatever. But yeah, that's how we can do that. All right, so that's block elements. They can be sized absolutely, relative to the viewport, relative to the container, or relative to their content, and we can position them using margins. However, we can't size them relative to their siblings. We can't position them vertically relative to the end of the parent, including centering them vertically, and we can't position them relative to their siblings. Cool. So what about inline elements? So inline elements, as a refresher, are all of those formatting elements plus image and video. And if you would like an inline element that doesn't have any semantics attached to it, then you're looking for a span. And again, you can make anything an inline element using display inline, but why? Maybe don't. Okay, so how do inline elements work? So we can start with sizing again. Sizing of inline elements is very simple. Size of an inline element is the size of its content plus its padding. You can't change the size of an inline element. So if we jump in here, we can see the span is this big. If we set a width on it, you can see it doesn't do anything. We set a height, also doesn't do anything. In fact, these days, the dev tools will tell you with this little pop up here, the display inline property prevents width from having an effect, right? So as long as it has display inline, the width and height won't work. You can change the size using the padding a bit, so that will get bigger, but yeah, width and height won't work. The two exceptions to this are image and video. You can set the width and height on an image and a video, I guess because they're replaced elements, but yeah, width and height on videos and images will work. Any other inline element won't work. Any inline element that has text inside it, it won't work. Okay, so what about positioning? Positioning of inline elements is a little bit complicated because before we can understand how that works, we need to understand line boxes. Now, line boxes are how the browser lays out inline elements inside block elements. And inline elements are always laid out inside a block element. So even if you create an HTML page and just put a span on it, the browser will wrap it in a body element, and a body element is a block element. Problem with line boxes is you can't see them. So there's no way to see them inside the dev tools or anything. The way that I think of them is like if you remember back when you're in school and you had to do an assignment where you had to make a poster. So you would like draw pencil lines on the poster and do your writing on the pencil lines and then rub out the pencil lines and it looked like you had magical, neat writing. That's what the browser's doing. It's penciling in lines and then rubbing them out. So when the browser goes to lay out some sort of inline content inside a block element, it's first going to add a line box. The line box is going to be the same width as the block element, and it's going to be as tall as it needs to be to fit its content. So in this case, the line box would actually have no size at all. It would no height at all because there's no content inside of it, but it's very hard to show things with no height. So just imagine. Okay, so once we've got the line box, the browser is going to take all of the content that needs to go in here, and it's going to break it up into tokens. A token is basically anything that has a space between it, so words. And it's going to try and place the tokens inside the line box, right? So it'll put the first token in the line box, second token, and it'll keep placing tokens until it gets to one that doesn't fit inside the line box. And then it's going to make a new line box, and it's going to keep laying out the content like this. All right, until all of the content is laid out in line boxes. And then it'll rub the pencils out and you won't see them. So a couple of things to note here is that if we have an element that is bigger, like if this has a font size that's bigger, then the line box that this particular element lives inside will be bigger. But the other line boxes will stay the same size, which means that if you have text that's different sizes, then your text isn't going to flow evenly down the page and it's going to drive your designers nuts. So I don't know what to do about that. You'll just have to deal with that. The second thing to note here is that if you have an inline element like this span that doesn't fit inside a single line box, it'll just break over two line boxes. It's no big deal. It's fine. You get this weird sort of looking deal with the background color and the outline or the border, but the browser doesn't care. Similarly, if you have an inline element inside another inline element, so they're nested, like this strong inside this span, then they live inside the same line box, right? Only the block element generates line boxes. The inline elements all live inside the same line boxes. And that's really the defining difference between block elements and inline elements. So block elements create line boxes for their content to be laid out inside of, and inline elements live inside line boxes, but they can't create line boxes. Okay, so what about positioning of our elements inside the line box? Well, if we look at horizontal positioning first this time, just like with our block elements, we can use margin. So if we go margin inline start, 30 pixels, so you're going to move the content to the right by 30 pixels, and we can go negative and move it to the left. The other way that we can change the horizontal positioning of inline elements is using the text align property on the container. So we can say text align start, which is the default value, text align end, which means align everything to the end instead. Center, which centers it, and my personal favorite, justify, which spreads it all out to take up all of the available space, like you're writing in some kind of 90s word processor. Isn't it great? When it comes to laying out things vertically, though, it's a little bit more complicated. Unfortunately, our trick from our block elements using margin top doesn't work. The element doesn't move. And technically, the margin is there. If we look at the layout here, you can see it's got a margin of 30 pixels, but it doesn't affect the position of the element. You can see the same thing actually if you apply a padding. You can see that the padding has been applied because the background has moved or stretched out to take up all of the padding, but it doesn't affect the position of the element. The only way to change the vertical positioning of an inline element is by using the vertical align property. So we can give it a number, like 20 pixels, and that will move it up above where it would have been by 20 pixels. It will also make the line box bigger so that it still fits inside the line box. If you give it a vertical value, then it will move downwards. There's also a bunch of keywords that you can use that sort of only really work if the line box is bigger than our element here. So let's give this other element a font size, a bigger font size. Right, so now our line box is bigger. So if we give this now a vertical line of super, it'll move it to like up just above the text, sort of like maths notation. If we give it sub, it'll move it down. Sub and super will actually change the size of the line box so that it still fits. We can also give it top, which will move it to the top of the line box, which won't have any effect if the line box is the same size as the text. We can move it to the bottom. And two other values are baseline, which is just the default, and middle, which I'm sure is something that we've all tried to use at some point, and it hasn't worked the way that we want. So normally, you'll try and use middle in a situation like this, where we've got some text and an image, and we want the two things to be aligned to each other's centers. We might jump in here and do a vertical align middle. And here you can see that not only does it not work, but if you watch closely, it actually makes it worse. Like the text and the image get further apart when we apply vertical align middle. The reason for this is that vertical align middle aligns the middle of the element with the baseline plus half the x height of the parent. So I'm sure that explains everything. On the off chance that that didn't explain everything, let's break it down. So the middle of the element, when we're talking about this span here, is going to be the middle of this blue box, right? So essentially where the red line is. The baseline is the point where you would write the text if you were writing, like handwriting it. So if we grab this parent container here and we give it a text decoration of underline, that underline is the baseline of the element. The x height of the parent is the height of the letter X in whatever font it's using at the moment, and half the X height is half that height. So about where the horizontal bar on the letter E is. So now if we set vertical align middle on this element, you can see that that red line moves down to where the horizontal bar on the letter E is. Right? So it's doing what it says on the box. It's just not what we want it to do. So how can we solve this? Well, there's a couple of options. First of all, we can grab this. The first option is that we can set vertical align on both the elements. So we put middle on this one, and we set vertical align middle on this one. Then they lined up. It works exactly the way we want it to. The other option is that we can not use normal flow again, and instead we can put a display flex and align items center on the two elements. And again, we get the same effect. They're aligned in the middle. The difference here is that if we use, if you see here, what you can't see is that there's a space between those two elements. And if we use display flex, that space goes away, right? So if this image was square, it would be hard up against the edge of that text. if we use the vertical align solution, then that space is maintained and everything is still laid out nicely. If you do want to use flex, then and you need that space, then you can use the gap property. We put like a gap of 0.5 m. That will add the space back in. I find that the vertical line is probably best if you just have 2 elements, but if you have a bunch of elements, then flex is going to work better. Cool. So that is inline elements. They are the same size as their content. They're positioned horizontally with margin or text align, positioned vertically with vertical align, and the vertical align is relative to the line box, right? So vertical align only works on inline elements, and if you're trying to use it on block elements, it's not going to work. Cool. So one last thing I wanted to address is this situation. So this element is a button embedded in some text. It's clearly an inline element because it's embedded in the text. It's in the same line box. However, it's also clearly a block element because it has a width and a height set on it. So what's going on here? Well, the answer is that it's actually neither an inline element or a block element. It is, in fact, an inline block element. An inline block is, in my opinion, a bit of a hack that was added to CSS to address the fact that when you set the display property on something, you're actually setting two different things. So if you set display block, you're saying that the element creates line boxes but can't live inside a line box. And if you set display inline, you're saying that the element lives inside line boxes but can't create line boxes. And there's no way to have an element that lives inside line boxes but also creates line boxes. Well, there is a way to do that because now we have inline block. So an inline block element is like a block element in that it lives inside, and then in that it creates line boxes for its content, and it's like an inline element in that it lives inside a line box. So we can see that if we adjust the text on this button, and we say button with lots of text good, you'll see that it's got multiple line boxes inside of it to lay out its own content, but those are not the same as the line boxes outside. And it means also that you can set the width and height on it, because apparently that's a thing that you get when you can create line boxes. One thing to note is that there is actually a new syntax for display, which uses two values to define display. So instead of display block, you can say display flow root or something like that. And one of the values refers to whether it creates line boxes and the other how it's laid out. The browser support for that, though, currently looks something like this. So it's probably not worth learning just yet, but having that concept in your mental model is probably going to be helpful. All right, so inline block elements, they live in their parents' line box, they create line boxes for their children, and you can set the size on them manually. Okay, so that's all I wanted to cover. So what did we learn today? Normal flow is everywhere, and understanding it is going to make your life a lot easier. Normal flow is trying to lay out a document, so that's what it's making easy. And if you're trying to do something else, you might run into trouble. We learned about block elements, inline block, and line boxes. And we learned that sometimes normal flow just isn't the answer. If you, again, wanted to look at the slides, they're at normalflow.ez.codes. If you wanted to learn more about layouts, MDN has a good article. And that's it. Thank you.